Welcome. So now we're going to find trig ratios given a ratio. Right? And here we have our steps. So when we're given a trig ratio, we know two sides of the right triangle. We don't know the third side, and we may not know the signs of our sides, because sometimes things like negatives cancel out. Sometimes the side we're looking for might be negative. All right, so let's go ahead and go through our steps. We're going to go through the same 3 steps for all of these problems. We're going to draw a triangle on the coordinate plane in the correct quadrant. All right, I will tell you which quadrant it is. Either I'll tell you the quadrant or I'll tell you between what degrees it falls. And we're going to mark the reference angle and label the sides based on the ratio. We'll use Pythagorean theorem to find the third side. And then step 3, we'll identify the requested ratio. Rationalize and simplify if necessary. Watch signs. All right, so on step 2, I don't have a lot of space here. I have a little bit of space where it says step 2, so we're going to do everything right in that little bit of space there. Next to step 2, though, I want to have you add one little thing, and that is determine if side is positive or negative based on, I'm going to abbreviate quadrant. I'll just put quad, based on the quadrant it's in. All right, so we're going to do step 1, step 2, and step 3 in that little space there, but it's okay because it doesn't take a lot of space. So step 1, let's draw a coordinate plane. Step 2, let's put our triangle in the right quadrant. So this is the first quadrant, this is the second quadrant, this is the third quadrant, and this is the fourth quadrant. All right, so we're in the second quadrant. The opposite side, the y, is always perpendicular to the x-axis. We go to the x, never the y. And then the other side comes from the origin to that point. There is our reference triangle. This is the angle we'll be using. This is really the angle that we're evaluating. But that's fine, right? But that angle and that reference triangle is what's going to help us set everything up. Now we're given a ratio. We're given that sine theta is 24 over 25. Remember which side sine uses, right? Sine is the opposite, which is the y, and the hypotenuse, or sometimes called r. All right, so that means that this side is 24, this side is 25. We are looking for one of the legs of the right triangle. Specifically, we are looking for x here. All right, so we're going to use Pythagorean theorem. All right, actually, I think I'm going to do steps 1 and 2 here, and I'll put 3 down right below step 3. I think I have enough space for it there. All right, so we're going to find our missing side. I just realized on step 3, I did not write down what ratio we were supposed to find. So I'll be writing that down. Otherwise, we don't have a ratio to find. All right, so let's take a look. And actually, I've got a book in the back of the room. I'll double check, make sure I didn't write one in, because I don't have one up here. All right, so we're going to use Pythagorean theorem. So it's leg squared plus leg squared equals hypotenuse squared. So x squared plus 24 squared equals 25 squared. All right, so, that's not a good sign. I don't know if you can see that, but it tells me I'm almost full. I got to get things off of here. So x squared plus 576, hopefully I can finish my video, equals 625. We'll subtract 576 from both sides. So x squared is 49. All right, now x is going to be the square root of 49, which could be positive or negative 7. All right, we have to think about the signs of so the hypotenuse is always positive, but x and y can be negative. And in the second quadrant, the x is negative and the y is positive. So therefore, we don't want 7, we want negative 7, right? Because we're on the negative side. Now I'm going to go grab the book that's in the back and see if I wrote down what we were supposed to find. Otherwise, I'll just make a decision. All right, so I got the book, and we are finding cotangent. I did write it down, all right? I just don't have it on mine anymore, unless it is below. Oh, there it is. It's below, but it won't move up. And it's kind of on the bottom of the page. Okay, so we do have it. And I'm going to lock that back. I would have realized it if I moved the page down. All right, so we're finding cotangent theta. Cotangent theta, remember, is the adjacent side over the opposite side. The adjacent side is the x, the opposite is the y. So the x is negative 7 and the y is 24. And we have found our ratio. All right, we did it. Those are all the steps, all right? So you draw your triangle in the right plane. You figure out what sides you know. You mark them on the triangle. You find your missing side using Pythagorean theorem. You think about, is it positive or negative based on the quadrant. All right, in the second quadrant, x is negative. We want the negative. All right, and then you find the ratio that you're asked to find. And that's it. Let's do 3 more examples. I don't think this will be too long, so I'm hoping it won't be too long so that I can save this. All right, and just where we go. All right, so, this one I can see what we're looking for. Find out for all 5 other ratios. All right, so we're solving when giving a trig ratio. This one is example 2. So we are going to, and we're going to, first of all, graph. All right, our coordinate plane. We are in the 4th quadrant. All right, so we go, vertical to the x-axis, and then straight from the origin. Sorry, I kind of overshot that a little bit, but there we go. All right, and then we're going to need to, let's also write down the signs here. Write down each of our quadrants. I probably should have done that before I graphed it. 1, 2, 3, and 4, just to remind you that that is the 4th quadrant. And in the 4th quadrant, the x is positive, but the y is negative. And we are given secant. So secant is the hypotenuse over the adjacent. And really it needs a angle. All right, so that means that the square root of 35 is the hypotenuse, and the adjacent is 5. All right, so let's go ahead and put that on our coordinate plane here. So adjacent is the x, so the x is 5, and the hypotenuse, the r, is the square root of 35. So we need y, we need a leg. All right, so we're going to use Pythagorean theorem. All right, so we have y squared plus 5 squared equals square root of 35 squared. All right, so y squared plus 25 equals, square and square root will cancel. This is 35. Subtract 25 from both sides. Y squared is 10. and that means y is the square root of 10, but it could be positive or negative, right, depending on what it is. So the only one that will never be negative, so you won't have to write positive and negative, is if we're finding the hypotenuse. That's never negative. That's always positive. All right, so in the fourth quadrant, the y is negative. So this is going to be negative square root of 10. All right, so now we're going to find the other 5 ratios, and I am going to need more space. So can I get this to move down? Where is, oh, I'll just hit this. Okay, you can still see the work. I didn't write anything above this right here, and then we'll find the other 5 ratios. So we need sine. So sine is, and of course theta is right there. This is technically the angle that we're finding, and then that angle and the triangles are reference angle. That triangle in the right quadrant gives us the right signs for the angle we're actually looking for, because it would be negative for some of the ratios. All right, so sine theta, remember, is y over r. So that's going to be square root of 10 over the square root of 35. And yes, we have to rationalize that. So multiply by square root of 35 over square root of 35, whatever's in the denominator. So 10 times 35 is the square root of 350. And now we may be able to reduce that. And so we're going to need to try. And then this would be 35. So, or simplify. We won't be, I don't know, we might be able to not only simplify but reduce. All right, so the square root of 350, that would be 35 and 10, right? That's what we multiplied. And this is 5 and 7, and this is 5 and 2. Yep, that's simplifiable. 1 5 comes out. 1 5 goes away. The 7 and 2 stay in the radical. So this is going to be 5 square roots of 14 over 35, which reduces. The 5 and the 35 are both divisible by 5, so that's 1 and 7. Final answer is square root of 14 over 7. So this one is a little harder than the previous one we did, and we're finding all 5. But we already know how to break down the 350 if that happens again, right? And so, but that's our only radical actually, the 10 and the 35. So we have finished the first one. So 350 is obviously not a prime number, right? And 10 and 35 are not prime numbers. So break it down and see if you can simplify it anytime you have a number like that. Cosine theta is x over r. So that's going to be 5 over the square root of 35. This time we just have to rationalize. So that is 5 square roots of 35 over 35. I'm probably going to do one column and then the other column for whoever doesn't fit on this side. Tangent theta is y over x, right? It's the opposite over the adjacent. So that's going to be, oh, you know what? I forgot something. I missed the negative that's on the square root of 10. So let me just add that to all of these. So it is negative square root of 14 over 7. I almost forgot that. Negative square root of 14 over 7. All right, and then tangent would be y over x. So that's going to be negative square root of 10 over 5, and that's that. So that one was easy. Cosecant, right, is going to have the same issue as sine had. That is r over y, right? So that is going to be the square root of 35 over the square root of 10. We'll multiply by the square root of 10 over the square root of 10. Oops. And I'm way at the bottom of the page here. You probably can't even see. Let me just move up a little bit. All right, so we already know that this is going to be the square root of 350. And now this is going to be a 10. Oops, that's too far. Oh, well, that's okay. You can see this really well, and if you need to go back to the other parts, you just rewind. All right, and we already know what this breaks down to. We already know this is, and I'm going to do it again. I forgot the negative. Here, we'll just put the negative in. I'll just put the negative in front. I just don't want to put that negative in. So all of them are going to be negative besides cosine and secant because of the square root of negative 10 that I keep leaving the negative off for. So we already know that this is going to be 5 square roots of 14 because we just did it right here, right? So we don't have to do it again. All right, and this is going to be 10. So I just put the negative in the numerator. It looks kind of weird sometimes in the denominator. You just need one negative. All right, so now we can reduce that because they're both divisible by 5. 5 divided by 5 is 1. 10 divided by 5 is 2. So this is going to be negative square root of 14 over 2. All right, and so now we have cosecant done, and we only have one left, and that is cotangent because we already know what secant is. We were given that. And cotangent is just x over y, which is really hard to see now that our board is kind of moved up. So that is going to be 5 over negative square root of 10, and we're just going to rationalize that. So that'll be negative 5 square roots of 10 over 10, and oh, look at that, we could reduce that. So divide by 5, this will now be a negative 1, and this will now be a 2. And so our final answer here is negative square root of 10 over 2. So this problem was certainly more difficult than the other one. We had lots of rationalizing and reducing, and we were finding all 5. So first one was pretty easy, and this one was a little bit tricky. All right, they're all not going to be tricky, but this one was a little bit tricky, but that's okay. All right, and so that's that. All right, so let's go ahead and try the next one. 2 more. All right, this time we are given tangent and in the third quadrant. All right, so so this is the first quadrant, this is the second quadrant, this is the third quadrant, this is the fourth quadrant. In our triangle, our reference triangle, maybe I'll put them in another color. So, all right, so actually let me do that better. So vertical, right from the x-axis and then to the origin, all right? So there is our reference. Oops, all right, I'll just move the coordinate plane since that one doesn't want to move. Boop. All right, this is the actual angle right here. And so all the way, where I can't seem to draw it, but all the way to that angle there is our actual angle. We are using this reference angle to evaluate. We are given tangent, and tangent uses opposite, which is y, over adjacent, which is x. So that means the y is 2 and the x is 5. Or is it? Because in this quadrant, both x and y are negative. So the negatives canceled. So both of these are negative. So you got to remember, right, that x and y are negative in the third quadrant, and tangent is likely to have been reduced. And so the negatives were canceled out. You have to remember, oh wait, those are negative, and just put the negative back. All right, but we're not going to have to worry about a negative on this one because we're looking for r. So r squared is 2 squared plus 5 squared, or it really doesn't matter about, maybe I'll put the negative in just to remind us it was negative. Not that it makes a difference, it's still going to be positive. r squared is 4 plus 25, which means that r is the square root of 29. Prime number doesn't simplify, right? And we are just looking for cosecant. Cosecant is the hypotenuse, r, over the opposite, so that would be y. So that is going to be the square root of 29 over negative 2. And it doesn't matter where the negative is. And, well, that one was pretty easy now, wasn't it? Because that's the end of this problem. All right, so you're just doing the same 4 steps, but sometimes you got to think. You got to think, you got to think about the sign. Is it positive or negative? Use the signs of the quadrant. You got to think about r. R is always positive, and you got to look back if you have to multiply radicals together. Do you have now a radical that has to be simplified? If you have a radical, is it in the denominator? Then it needs to be rationalized, and can you reduce? Right? And in this particular problem, we can't do any of those things. So it is what it is. Square root of 29 over negative 2. All right, let's go ahead and try the next problem. I think this is the last problem. Yeah, because this is the 4th one, and there was only 4. And there we go. So we are now in the 3rd quadrant again, actually. All right, and we're just looking for one thing. So this is another easy one. All right, so 3rd quadrant, right, we come down, right, and then from the x-axis and over to the origin. All right, and we are given cosine, and cosine is the adjacent over the hypotenuse, and the adjacent is x, and the hypotenuse is r. The negative has to go on the x because the r is always positive. Usually it would just be in front, so just because it's on a number, if this was cosecant and I just wrote, or if this was secant and I just put negative 5 halves, right, then negative doesn't go on the 5 because that's the hypotenuse and that's positive. Right? So you have to think a little bit, but it does go on the 2. So this is negative 2, this is 5, we're looking for the y, right? So that's the leg. So we have y squared plus negative 2 squared equals 5 squared. So that's going to be y squared plus 4 equals 25. Another one that doesn't simplify. This is going to be y squared equals 21, which means y is the square root of 21, but it could be positive or negative, right? If it's not r, it could be positive or negative. And in the 3rd quadrant, remember, the x and y are negative, so this is negative square root of 21. All right, we are looking for tangent. Tangent is the opposite over the adjacent. The opposite is the y. The adjacent is the x, so this is going to be negative square root of 21 over negative 2. The negatives will cancel. So square root of 21 over 2. So we had 3 really easy ones and 1 pretty challenging one, but that balances things out. So that's the end of this video. So thanks for watching, and bye for now.